let's get into some of the games you're going to be playing. We're going to estimate some stuff by making some frickin' rectangles underneath a curve. So, game is find the area of however n rectangles. So we're basically going to find the areas of rectangles. Then we're going to add up our frickin' answer. And then we're going to be stoked and we're going to walk away. That's the game. Let's look at it. It's called a Riemann sum. There was somebody back in the day named Riemann. We won't get into it. And now, gentleman's got something called Riemann sums. It's all named after him. How dope. So what we're looking at here is, we got a function. It's sine x. Real simple. We all know what a sine wave looks like. We know it goes up and down, in between -1 and 1, blah, blah, blah. But we just want to look at it on the interval from our x values going from -π/3 up to 5π/6. And I'm just going to write it in now. These intervals, we always call from A to B. All right? From A to B, closed interval. Cool. So we got a function, sine of x. We have an interval. And what it wants us to do is we want to estimate the area under the curve of f on the given interval by finding L7. Now what the hell is L7? That's saying that we want to use our left-hand limits, and break it up into 7 frickin' pieces. 7 pieces. So we're going to make 7 different little frickin' rectangles. So I got a little picture I drew up down here. There we go. Y is equal to sine of x. And we have it represented here that we get our going from an interval from -π/3 on up to 5π/6. I already got that written in there, huh? 5π/6. No other numbers are written in. And we're going to break it into 7 different pieces. 7 pieces. And we want to approximate it by doing L7, which means we want to make left-hand rectangles out of this. So if we're going to break this into 7 pieces, we need to know how wide are all of our rectangles. So let me draw one of them in here and be like, left hand, bang, rectangle, left hand. And notice I'm drawing in red. Areas underneath the curve, like underneath the x-axis in red, this is actually negative area. Weird shit. Negative area. What we have up here in green when we start making our left hands. Whoa. Our left hands. This is all positive area. Okay? Just breaking them up. Oh, it's like I'm cheating here. I think I already know how it's going to get broken up. I do. It's all cooked up. So we're going to be using all of this to estimate the area underneath that curve. Now my drawing doesn't show up, but the width is always the same. Of course, mine's by hand, so it's not perfect. So let's see if we can't find the width. And by the width, we call it that change in x. And this is the change in x. It's the base of our frickin' rectangle. So if we had any one of our rectangles and we're looking at it, we'd say the base is the change in x. And then we would say that the top, this would be f of x sub I. Whatever x value you're plugging into sine, right? Oh, because I wrote in y. You should call that f of x is equal to sine of x, right? We say f of x is equal to our sine of x. That's also y is equal to that. And our x sub i's, they're all right here. -π/3, -π/6, 0, π/6, π/3, π/2, 2π/3. Your x values, the shit you're going to plug in. So you can find your heights. So for our first frickin' rectangle, our first one we're looking at that we're going to add up, we got 1, 2, 3, 4, 5, 6, 7 of them. Weird, I broke them up into 7. Let's go find that width. Let's go find that change in x. So the change in x is equal to b minus a all over n. But we have all that stuff. There's a and b. So it's b is 5π/6. A is -π/3, and we divide by 2. Oh, that ends up being π/6. I figure y'all know how to like add and subtract and divide and shit. It ends up becoming 7π/6. Oh shit, did I write it over 2? Gosh dang it. How many pieces are we breaking this into? 7. Because up top it becomes 7 pi over 6, and on the bottom it's 7. It cancels out, becomes pi over 6. My bad for missing that. I put a 2 under there. All right, so we now know our change in x as well. We know our width for every single one of our rectangles. Our change in x is equal to pi over 6. That's how I have it gapped out from negative pi over 3 to negative pi over 6 to 0 to pi over 6 to 2 pi over 6 to 3 pi over 6 to 4 pi over 6 to 5 pi over 6. All broken up into those pieces. So let's add up those rectangles. Let's go find out what our heights are going to be. So first thing we're going to do is we're going to pop in our first one, whatever this rectangle is. So we're going to say our first area is going to be, what's that going to be? Oh, it's our change in x times the height. It's just base times width. It's our f of x naught times our change in x. It's the first place, or f of a times our change in x. There's a. That's where we begin, huh? Our f of x naught tells us that's where we start. So our f is sine of times pi over 6. And what is it? Negative pi over 3 is our first one. That's our first. So we end up with, that's equal to negative root 3 over 2 times pi over 6. And cool, we found ourselves an area. Now let's add it to our next one. We're going to go to our next, and that's f of x sub 1. Our next number, it's kind of hard to see back there, but that's negative pi over 6. So we're like, oh, this is going to be, well, I'm not going to write this shit in there. Let's just keep going down to the next. And we're going to say that this is going to be plus sine of, and we're going to pop in negative pi over 6 times our change in x, which is pi over 6. Plus, we move to our next one, and that's going to be f of 0 times our change in x. So that's plus sine of 0 times our change in x. We keep going. We're playing this game. We just keep going to number, to the next number, to the next number, to the next number. But the only one we're not going to use when doing from the left-hand side is the very far right one. We won't use the 5 pi over 6. So I'm going to continue to write this thing out in this horrible form. Sine of 2 pi over 6 times our pi over 6 plus our, oh geez, how many more do I have to go? Just a couple more? All right, sine of pi over 2 times that pi over 6. And gosh dang, this is terrible. This is so much work that we're doing. Keep writing that pi over 6 over and over and over and over. Do you see that it's on every single freaking term? It's on every term. Now this is equal to our L7. We've now have this god-awful thing hanging out right here. Maybe we could have simplified it down a little bit more. So we take this and sine of negative pi over 3. Oh, let's not do that. There's a pi over 6, 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 and a pi over 6. You mind if we just factor that shit out to the front? So we get pi over 6 times our sine of negative pi over 3 plus our sine of negative pi over 6 plus our sine of 0 plus our sine of pi over 6 plus our sine of pi over 3 plus our sine of pi over 2 plus our sine of 2 pi over 3. And now it just all boils down to knowing your freaking answers. This is equal to, oops, negative 1/2. Let me change that. Sine of negative pi over 3 is negative root 3 over 2. Sine of negative pi over 6 is equal to negative 1/2. Sine of 0 is equal to 0. Sine of pi over 6 is positive 1/2. Sine of pi over 3 is positive root 3 over 2. Sine of pi over 2 is equal to 1. And sine of 2 pi over 3 is equal to root 3 over 2. As we can see, those shit goes away, and it looks like we're just going to end up with an exact answer of pi over 6 times 1 plus root 3 over 2. That's pi over 6 times 2 plus root 3 all over 2, bringing it in. That's pi times 2 plus root 3 all over 12. I don't know why I kept going. I just wanted to do it for fun. And there it is, and I did it without a formula. I just kind of ran it through. So there's your L7. Shows all the values inside of here that did not include the far right value for our left hand. Let me write out what this formula really was that we could have found our L7, and I'm going to put this into fancy terms. That this is going to be equal to your f of x sub naught plus f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus f of x sub 4. And I'm going to go all the way up to, but I will not include this. I'm going to go up to 6. And I don't want to include the 7 because that's the far right point times our change in x. Now the difference between when you do your right hand one, which is actually your quiz, is to find R7. That's your quiz that's going to be due. So make sure to get that done, huh? I'll be posting that thing up soon. I actually just came up with that right now because I realized I don't want to do the last one. I don't want to do it. You get to do it. You're going to turn it in. Everybody's going to get points. You're going to be stoked. But on this one, notice I did not start at 0. I started at 1 for the right hand because we don't include the far left one when we do the right hand. So we continue going on, and we will go down to that f of x sub 7. And we'll multiply it by our change in x. So there's your two formulas all broken down. I wanted to just kind of do it by hand and kind of get you the idea. But this is going to be the formula that you will need right here in order for you to do your quiz. Because your quiz is to do this same problem, except don't do L7. Your quiz is for you to do R7 with all the same stuff right here. You will consider the function f of x is equal to sine of x. That graph down there, we're still going from negative pi over 3 to 5 pi over 6. Our change in x is still going to be the same thing. The n is still the same thing. All you have to do is not include the same sort of endpoint. So here's all the work done for you. Go get into that quiz, because the next time we do stuff, it's not going to be adding up numbers. You're going to be doing sums and all kinds of shit. Oh, can I write this down just differently? I just want to write this thing down. Nah, I won't do it yet. We'll get you next time. I'll see you.